Hey all, I hope you all are doing extremely well. So in this video, we are going to discuss problem of the day on the Geeks for Geeks platform. So today's problem is even and odd, right? So we are going to discuss about this problem and the logic and the code part as well. Sorry for missing the videos for some of the POTD, right? So in this video, I'm going to cover this question as well. This was the previous POTD for yesterday, that is maximum GCD of siblings of a binary tree. So we'll be covering that question also in this video itself. But first, let's cover this one. In case you are interested to watch this one, then you can just follow the timestamp in the description so that directly you can start watching this one, right? So first, let's discuss even and odd, right? So the problem statement says, given an array ARR of size n containing equal number of odd and even numbers, arrange the numbers in such a way that all the even numbers get the even index and odd numbers get the odd index. Note there are multiple possible solutions. Print any one of them. Also, zero-based indexing is considered. For example, so n equal to 6 is there, 3, 6, 12, 1, 5, 8. So what they're asking us to do is that we have to arrange the numbers that we're having in the array in such a way that all even numbers should be at the even index and all the odd numbers should be at the odd index, right? So here we are getting the output as 1, right? So the explanation is that 6, 3, 12, 1, 8, 5, 6, 3, 12, 1, 8, 5 is a possible solution. The output will always be 1 if your rearrangement is correct. So what is going to happen, that we'll be making that rearrangement in the function that is given to us, and if our rearrangement is correct, right, so that they are checking, we don't have to worry about this. So if our rearrangement is correct, then output will automatically be 1. Okay, so example 2, so for that as well we are getting 1. So what we have to do is we don't have to read any input or we don't have to print anything. Our task is to complete the function rearrange, which takes an integer n and an array ARR of size n as input and rearrange the array in place. In place they have mentioned, right? In place, you don't have to use any extra space, without any extra space. Okay, so expected time complexity they have specified and auxiliary space as well. Well, the question is pretty easy, right? Somewhat similar to that of a, like, you must be thinking that can we do something similar to that of a two-pointer approach or something, right? To keep track of the things. Well, yes. So let's understand the logic now. So let's say we are having this array, right? And here we have to do the arrangement. So first of all, let me put the indexes here, 0, 1, 2, 3, 4, 5. So what we have to achieve is we have to achieve the arrangement where even elements are at the even index and odd elements are at the odd index, right? So with respect to that, what we can do, we can take two variables. Let's initialize I with 0 and j with 1, right? Because we have to keep track of that even and odd things. So here we have I and here we have j, right? So we can do what? We can take a loop, right? Something like this. So we have to continue in this loop till the time I value is lesser than that of n and j value too lesser than that of n. See guys, now if the arrangement that they are asking from us, that they are expecting, if it's already there, so we don't have to do anything. What I mean by this, that if all the elements that are even, they are already at the even position, we don't have to do anything. Odd elements are at the odd position, we don't have to do anything. So with respect to that, what we can do is we can simply put a while loop here. We can simply check, right? To be on the safer side, make sure to check this condition that I should be lesser than that of n. So I here is keeping track of that even position, right? So what we can check is that I less than n and the element, let's call this array as a, element at a of I position mod 2 equal 0 means at the even position the element that we do have, if that is even. So what we have to do, if here as of now that is 3, but let's assume the element at 0th position that is even. So what we have to check, we have to check on the next even position, right? That's what we have to do. So how we will update the value of I then? 0 we have checked, now we have to check the 2. So we'll be updating the value of I is I plus equal to 2, right? Same thing we can do for odd position also. So here also, while j is less than n and a of j that we do have now, a of j that is at the element at the odd position, if that mod with 2 is not equal to 0 means that is odd. So see, if here at the first position, let's assume for now although it's 6, but let's assume there is an odd element, right? So if there is an odd element, Okay, at the odd position, so we are okay with that, right? So next we are checking another odd position, so that is 1. The next one will be what? 3. 2 plus 1, 3. So we have to update for the next one as j plus equal to 2, right? But if that is not the case, right, if that is not the case, so what will happen? It means that we have come across a even element at the odd position or the odd element at the even position, right? So again, to be on the safer side, put a if condition that I should be less than n and j should be less than n. Now here what we can do is we can swap a of I and a of j, right? And we can increment the value of I plus equal to 2 and j plus equal to 2, right? That's it. So let me give you a quick idea about the code. So what we are doing, see, let's refer this array now. So I value is 0, okay, j value is 1. So 0 is less than that of n is what? 6. 1 2 3 4 5 6, right? So I is less than that of 6 and a of I is what? 3. 3 more 2 is not equal 0. We will come out of this loop, right? Just while loop. Next we will check for this j. So 6, okay, 1 is less than that of 6 and a of 1 is what? 6. 6 mod 2 not equal to 0. This condition is false. We will come out of the loop. Now here these conditions satisfied. So we are saying to swap the value of a of I and a of j. What will happen? 6 will come here and 3 will come here. So now see, now what do you want to check? We want to check the next even position and next odd position. So hence we are updating the value of I plus equal to 2 and j plus equal to 2. So I will be pointing to this one now and j will be pointing to this one now. Okay, okay, this is I and this is j. I will be pointing to 2, 0 plus equal to 2, 2 and 2 plus 1, 3, okay, for j. Now again this value condition is true, right? So we'll be checking again this condition is true and a of I. So at a of 2 what do we have? 12. 12 mod 2 equal 0. The condition is true. So we're not going to make any changes here, right? Now I plus equal to 2. So we are checking for this position, this fourth position, right? So this time the condition is not true, right? Because 5 mod 2 not equal to 0, right? So we will come out of the loop and I position is what? I position is 4, okay? And for j also we're gonna check. So you can see 1 we do have at a of j value is what? 3. At a of 3 we do have 1. So this is odd. We are not going to do anything. Then we'll be updating the value of j. So j will be checking for that one. So here we do have 8. So while loop will break, right? We will come out of the loop, right? The condition will break and we will come out of the loop. So what do we have now? J value is 5, right? So again we're gonna do swapping for a of 4 and a of 5, right? So 8 will come here, 8 will come here and here will be 5. So 6 3 12 1 8 5, okay, okay. And now I value will be what? 6 and j value will be what? 7. So condition will become false, condition will become false, right? So you can say this is the arrangement that we have got: 6 3 12 1 8 5. And you can make sure, see, at the even position we have the even element, even position even element, even position even element, odd position odd element, right? So we have got the arrangement, right? So I hope the logic and the code part is also clear, because pretty much we have covered all the code here itself. But even though, let me share you the code part even. I hope that is clear. So here you can see we have written the same logic that we discussed just now, right? So okay, so here we have written this swap function by ourselves, right? So I have provided the complete code in the description. I hope the problem statement, the logic and the code, everything is clear to you. So now let's hop on to the next question of this video. So here the question is maximum GCD of siblings of a binary tree. So before understanding that, make sure to subscribe my channel if you haven't subscribed the channel till now, and do join our Telegram community as well. The link for the Telegram channel is given in the description itself. So let's understand the problem statement now, that we have been given a 2D list that presents the nodes of a binary tree with n nodes. The task is to find the maximum GCD of the siblings of this tree without actually constructing it. So we don't have to construct it, they have clearly specified it. If there are no pairs of siblings in the given tree, print 0. Also, if given that there is an edge between A and B in the form of A comma B in the list, then A is the parent node. Okay, so what is saying is that if there's an edge between A and B, okay, in the form of A comma B like this in the list that has been given to us. So A is the parent node. That is clear, right? That is clear. Okay, so n equal to 7 we do have. So here you can see this is the array 4 comma 5, 4 comma 2. So this is representing what? An edge. See here also now what they have specified that there is an edge between A and B. So what would be the parent? A would be the parent. So here 4 is the parent of 5, 4 is the parent of 2. Similarly here also you can see 2 comma 3. So 2 is the parent of 3, 2 is the parent of 1, and 3 is the parent of 6, 3 is the parent of 12. Right? So this is what is expected from us. This is the tree, right? This is the tree. So you can see 2 is the parent of 3 comma 1, then 6 comma 12, 3 is the parent, right? And okay, and for 2 comma 5, 4 is the parent. Now so we have to check the maximum GCD for siblings, right? Siblings we have to consider of the tree. So what would be the sibling? So we don't have to consider the parent, right? So here 5 2 3 1 6 12, right? You must be getting it. Okay, so for the above tree the maximum GCD for the siblings is 6, which is formed by the node 6 and 12. This one, right? This one 6 and 12 for the children of node 3. These are the children of whom? These are the children of node 3. Okay, and here we have another input. So n equal to 3, 1 comma 2, 1 comma 4. So 1 would be the parent, 2 and 4 will be the children. So we have to basically, so here we have to basically return the GCD of 2 and 4 only, right? Because there is just one parent and having 2 children. Okay, so here you can see for the above tree the maximum GCD for the siblings is 2, formed for the nodes 2 and 4 for the children of 1. So we don't have to read input or print anything. Our task is to complete the function max bin tree GCD, which takes an integer n and a 2D list denoting the edges as input and returns the maximum GCD of siblings of the tree. Expected time complexity has been specified where E is the number of edges in the tree, right? And expected auxiliary space is also been specified, right? So for now, how we can solve this problem? So the most basic approach that must be coming to your mind is that, see, it's all about that we have to deal with the sibling, and sibling will be right, like for whom the parent is same. Okay, the for whom the parent is same. So what we can do is to keep track of that parent child thing. The most basic way that you can follow is that we can take a hash map, right? We can take a hash map and we can simply iterate through all the entries that we do have in ARR, right? We can simply iterate through them. So X value, we know that it denotes parent, and the Y value, right here you can see we are going through the each pair that we do have. So le dot get 0 means this is pointing to the first one, and le dot get 1 means the next value that we do have in the pair, right? So X is denoting to parent and Y will be the child, right? So what we are doing is we are putting this child parent entry in the map, right? So if this entry is already there for a given X, for a given parent, if it is already there, it means we have come across another child of that particular parent. It means that is a sibling. Sibling of whom? Sibling of the value that is already there or associated with that key X. So what we have to do? We have to find the GCD, right? So you can see here we are doing what? This Y that we have got just now for a pair for whom the parent is X, and the value that is already there in for this particular parent, right? For example, this you can let's understand in this way. So first we come across this entry, right? So what we're doing is that for this key, it means for 4 the value is what? 5. For 4 is the parent and 5 is the child. Next time when we will come across this pair, right? So here you can see we are checking mp.getX, means if this value is not equal to null, means there is an entry already. So entry is there, of course. You can see mp.get4, if you will do, you will get 5, right? You will get 5. So here what we will do, 5 is the sibling of 2, it means, right? Because they both belong to the same parent. So here we are taking the GCD of 2 and the value mp.getX, which is nothing but 5, right? And we are storing the max GCD because we have to find the max GCD of the siblings, right? We are storing this in this max GCD variable, right? So this is how we are keeping track of the things, right? With the parent we are mapping a value. Okay, so I hope that you must be getting the idea. Like how to do this. But what is the problem with this approach? This is fine and it will work good. But the thing is that here we are using the extra space, but in the question what they are expecting from us to not to use any extra space. So can we do any further optimization on this one, right? Is there a possibility that we can further optimize it, and we can do this in constant space? Oh well, yes, we can do. The thing is, what we can do is we can sort this array that we are having now, that array list of array list that we are having. We can sort this on the basis of this first element, right? On the basis of this parent, right? So we can sort them and we can do the comparison, right? For example, we took this pair and we compare the element that is there at the 0th part. If it is equal to the element that is here, the current pair at the 0th part, if they both are equal, it means they both are the next element that we do have in the pair. They both are sibling because for them the parent is equal. The parent is equal, right? So we can do the same thing, right? We can do the same thing, this GCD thing there also. Just the thing is that we'll be sorting this array list of array list on the basis of what? On the basis of this parent, on the basis of this key, right? And just the logic is all almost going to be the same. So let's have a look on that code as well. So here you can see what we have done is, first of all, we have done the sorting, right? From beginning to end, we have done the sorting. Then this variable to keep track of the maximum GCD. Now we're starting a loop in type equal to 1, I less than arr dot size I plus plus. Now what we're doing, see, we have to check for the parent, right? So this I value will keep on changing. Okay, we are initializing this 1, 2, 3 like this. It will keep on changing. This 0th element should be the same, right? Because we are comparing that only. We are having a 2D array kind of thing, right? So that's why we are accessing like this arr of I comma 0, arr of I comma 0, right? So we are comparing this with element that is there at arr of I minus 1 comma 0. For example, we are having something like this 4 comma 3. Let me check. Okay, we were having something like 4 comma 3 comma 4 comma 5, let's say. Okay, right? So okay, this is what we're having. So this is first pair, this is 0th pair, let's say this is first pair, right? So we have initialized with 1. So what we are doing is arr of 1 comma 0. It means what? This element 1 comma 0, if it is equal to arr of I minus 1, which is 0 comma 0, what is the element? 4. So they both are equal, right? We have done the sorting. Let's assume we have done the sorting. Okay, sorting we have done. So now here you will see 4 and 4, they are equal. It means this element, right, the next element in the pair, they both will be what? If the parent are similar, they both will be what? Siblings. So we are doing the same thing that I just showed you in the Java code, right? So int val equal to GCD of arr of I comma 1 and arr of I minus 1 1, because they both will be the sibling, right? And we are just putting this maximum GCD because we have to keep track of the maximum GCD for the sibling, and at the last we are returning maximum GCD. I hope that would be clear because the question was pretty easy only, right? So thank you so much for watching everyone, and make sure to subscribe my channel. It will motivate me to create more such content for you. And thank you everyone for watching. Don't forget to join our Telegram channel. Bye bye.